Flowchart is our attempt to bring the ocean closer to people. We wanted to take something that feels abstract and inaccessible, like NetCDF files full of numbers, and turn it into something anyone can interact with by just asking questions. For now, we are proud to have built a system where you can truly say that you asked the ocean a question and it answered. So let's look at the front end. You open up to a login page where we've used admin credentials to test it. That takes you to the landing page, which tells you a little bit about Flowchart and what it does, which is ingest data, reason over it, and help you visualize with constructive insights. So let's look at the chat first. As you can see, there's a chat memory and history. So let's look at some previous chats that we've used while testing the product. So as you can see, there are cases where you make a mistake or a typo that it accounts for that and spell correct. So you can see that we're implementing NLP in its truest sense. So let's look at an example query. For example, salinity in the Arabian Sea, where it gives you an insight-driven graph that's interactive and full of information. So you can zoom in, view the individual data points, and it also extrapolates the data to give you larger insights. The point of these graphs is to make it human readable and to make it easy to auto-detect anomalies and view things like climatology without having to go through too much work on your own. Now let's look at the map component. This is a live map of all the Argo floats that we currently have access to, whose data we currently have access to. You can filter them by the core Argo floats that show you things like temperature and salinity. Also the BGC, which is biogeochemical floats. Each float marker gives you information on the float, the current float profile, and the variables that it is showing you. The next page is the Learn About Argo page, where students and educations and people new to the project can view basic details, look at key oceanographic terms, and learn more about the project. And finally, let's look at the Control Plus C Argo program itself, which we'll talk about in the pipeline section. Now, this is a multi-agent system, as we'll see. It uses a planner, SQL, retriever, visualization, and reporting agent. So the raw NetCDF data goes through a parsing script and gets loaded into vector databases and a structured database. When you enter a query, such as the average salinity in the Arabian Sea, you can see that the user query goes to the planner agent first. The planner agent then decides which agents to send it to. For example, the retriever and SQL agent to collect the data from the databases. This data is then sent to the visualization agent to create visualizations on demand. As you can see, after processing, it gives you a graph of the average salinity. Let's look at another example query, right? For example, compare the average surface salinity at the Bay of Bengal. So as you can see, it follows the same process. User query to the agents, agent sends it, the planner agent sends it to the retrievers to get the data on demand, where it goes to the visualization agent and response composer to give you a little bit of insight about the data that you've queried. So you can see the salinity comparison. And now to show you the context awareness of the model, if you ask it to display the same query but over a certain time frame, let's just wait for this to process. What will happen is that it will give you a different graph, and that graph will basically go from just showing you a basic bar graph to it will show you a comparison of the same features that you saw earlier, but over the exact time period that you asked it to show you for. As you can see, January to December 2004, it's comparing the average surface salinity. Now let's look at the backend. We use a multi-agent system because since there's so much data, you need to load the individual files that are requested by the user. For example, now we're working with over 31 million rows of data. So when you're dealing with such big data, it's hard to load it all at once. And so it makes sense to do more specific retrieval. So, and the planner agent, you can see connects to the database, and it has certain functions that help it to decide which agent to call. For example, retriever or SQL or maybe both. And it passes data in JSON. The SQL agent has inbuilt functions that help compute climatology and other insight-driven parameters. So that helps you with your insight awareness and extra information. And you can see that it converts natural language to SQL. Yeah. and then you have code to pass data regarding that, the SQL data that is retrieved, to the visualization agent, which we'll see next. So the visualization agent, this is what takes the data from the SQL and retriever agents and turns it into the interactive graphs we see, and the retriever agent which pulls from the vector database. And you have your main functions and your chat and memory. So the memory is part of the MCP, Model Context Protocol. This is used to store chat memory to allow the LLM to use context and remember what you said to it.